Unlike the previous problem, this problem wants you to actually work with data and calculate some of these things. So let's do that. We're going to go to a spreadsheet. So what I did is I copied and pasted this data directly into Excel, which here it is. That's not it. Here's, called it lesson 44. Actually, this was not it either. Here it is. So this is the data that I just copied and pasted in there. And the first thing I have to do is calculate the average of the y values. So I'm going to go down here and I'm going to type average. And here in Excel, the command is equals average. You see it show up here, average. Doesn't seem to want to do that. I'm going to type it out. And then I'm going to go, my first data point starts in B2, and I put a colon and a B11. That's where my last data point. And see, it highlights all of these. So I want to find the average of these guys. I'm going to hit enter, and it gives me the average of these values. And these values in context were the time to next eruption. Whoever did this, they use R. This came from data from R, which you will use in 206. So this is in cell B12. Remember that. Here I'm going to calculate the sum squared total. Right? How do I do that? Well, I have to take the error. So I take B2 is my actual data point. B12 had my average. And I put a dollar symbol there because I want that to not change as I scroll down. And then I'm going to square it. That's the error between the data point, 97, and the average. Hit enter. That gives me the sum square error between that data point and the mean. And I'm just going to scroll this thing down to 11. So that gives me all the sum square error between the mean and that data point. Down here, I want to total that up. Equals sum. Sum is the word I want when I want to add everything. C2 to C11. And that gives me, this guy right here is the sum squared total. So if I went back to the WebAssign problem, let me see if I have it in there. I took out the answers, but the answer there is, that's what goes in here. What goes in Y bar? That's the average. So I already calculated that. Here, if I go back here, the average is 76.9. So 76.9 would go into the Y bar, and an SST would go this number right here, the C12. All right, so what's the next thing they ask for? They ask for a prediction. And they gave me a formula. Y is 0.25x plus 30. So in here I'm going to type equals. My x value is the seconds, the duration. And I'm going to use the duration to predict the eruption, the time to the next eruption. And so I'm going to put 0.25. My x value is A2 plus 30. So the predicted value is 97, and the time to eruption is 97. So it did pretty well on the first data point. Now, show you a trick. If I double click, see how my cross becomes thin right here? Double click that, it will scroll down. Let's go down to the bottom. So it did that. These are all the predictions. You can see all the error. This is the error, only the error, or the predicted. How well did I do? Well, the first thing I want to do is actual. The actual value is in B2. And the predicted value is in D2. And I'm showing you a good habit. I model for a living, not the beautiful kind of model, because I definitely don't look that right now, but I do mathematical modeling for a living. And I don't want to square everything. I kind of want to see how things shake out with my eyes. So actual minus predicted, I usually do as a separate column. So I can see there's a huge dip negative here, here's a huge dip positive. It's over and underestimating both. And that's what this column tells me, and I can just look with my eyes. I see this minus 10 here. It looks like more often than not my model's under predicting than, or it's over predicting, because it's negative, it's over predicting. But then here I'm going to square this E2 squared is just the error squared. Let's scroll this down. Double click that and all these things fill in. And SSE is going to be the sum of all these errors. So we can either do it on top or bottom. I can do it here. Sum of F2 to F12, 11, sorry. Sometimes I do that error. It'll scream at you if you do that error and try to actually, it'll say something like circular. Well, I'll show you. If I do 12, well, I'm inside 12. If I do that, it'll say one or more circular references. So what you did is you need to change this to 11 because you just want to sum those. So the sum squared error is 406.5625. So let me put that up here. And put equals, and that was in cell F2. So there's that sum squared error. So in your sheet, it asks for sum squared error. That's what goes in sum squared error. It's the total error. And then the next thing they ask for is the R square. The formula for R square is sum squared total. So where was sum squared total? Let's just put another cell in here. Sum squared total, that was in cell C12. So R squared is going to be 1 minus sum square error divided by sum squared total. It's the ratio of your model, which you think is the best because it's your model, and the worst model, which is the mean. And so if I do that, it's 1 minus sum squared error is H2, G2, and I just crunch it through. My R square is 0.78, and that's what goes in the R square. And if you need help with this, my number is 973-224-2562. You can pause me and slow down. So you can pause things and slow down and check things out. And I think they also ask you, like, what is it here? I mean, like, all of this is pretty straightforward. So you can call me or text, just send me a text. If you're not in my section, if you're in my section, you have my number. If you're not in my section, all you have to do is introduce yourself, tell me who you are, and ask your question, and I'll help you out.